Hello guys. So in this chapter, this is a continuation of multivariable calculus, and we're going to talk about gradient vector field, conservative vector fields, and also we're going to talk about the curl and the divergence. So at the end of this video, you'll be able to one, find the gradient field or the gradient vector field of a function, and also find the curl and the div of a function. So let's get into it. So let's start with the gradient vector field. So when we talk about gradient vector field, right, you know that there's a vector, it has directions, right? So this application of, I think, vector from is it algebra, that is math 151. Yeah, I think that's first semester in 1100, but I think you can record that. So then, given a function of x, y, z, then the gradient vector is defined as, we have the gradient vector. This is a delta f, which represents the gradient vector. So always note that the delta f is the gradient vector. What does it mean? So you know that the gradient vector, you're just going to partially differentiate the function with respect to x, then comma, partially differentiate the function with respect to y, comma, then partially differentiate the function with respect to z. In this case, you know that the bracket here is different, so we are representing it by what? A vector. So you know that the vector field has direction and a magnitude. So in this case, you're going to represent it by the partial derivative of the function with respect to x. No, you're going to represent it by I plus the partial derivative of the function with respect to y. You're going to do it j, then plus the partial derivative of the z with respect to the partial derivative of the function with respect to z. You're going to bring k. So that's why they brought the ijk. It's very important because when you understand this, it's going to help you to when finding the curl and the div. It's very simple. So note that you know that the variables can be 2 or 3, right? So in this case, when the variable is 2, that means that you're going to get only f of x and f of y. In this case, you're going to get I and j. So that means that you're going to get the gradient vector will be f of the partial derivative of the function with respect to x, the comma, the partial derivative of the function with respect to y, because the variables here are only 2. But in 3 cases, you also use this. So in the 2 cases, you're not going to get a k, but in the 3 cases, you're going to get a k. Let's load this. In these cases, the function of what? X, y, z is often called a scalar function to differentiate it from the vector field. So you have the scalar function which differentiated from what? The vector field. Example for us to understand it very well, right? Let's take one example. So in this example, they are asking us to find the gradient vector field of the following, right? Yes. So let's take question number 1. Let me explain it with question number 1. With question 1, we finding the gradient vector field. Then let's go to this. How many variables do we have here? We have only 2 variables. In this case, that means that you're going to differentiate the function with respect to the x variable and partially differentiate the function with respect to the x variable and partially differentiate the function with respect to the y variable, right? So let's go here. So you finding the vector field, that's the gradient vector field. You just need to bring this bracket. You are going to partially differentiate this with respect to x, which will give you 2x sine 5y. That's what they did it here. And then you differentiate it with respect to y. That is going to give you, you differentiate the one in the bracket for, you're going to get 5 multiplied by the x squared, then this will be cos 5y. That's why they had this. As I told you, this is in terms of 2 variables. So you're going to do the partial derivative with respect to only the 2 variables. With number 2, it has 3 variables. In this case, you're going to do it with respect to 3 variables. So partially differentiate x with respect to partially differentiate the function with respect to x, whereby you're going to get this, right? Because you're going to differentiate the top, which will give you negative y, then multiply it by z e exponent negative xy. That's what he had this way. And then you are going to partially differentiate this with respect to what? Y. You get this, and partially differentiate it with respect to z, and you get this. So this is very simple. For us to find the gradient vector field, it's very simple. You are going to take their partial derivative per the variable provided. And very simple as that. But if they ask you to find the vector field, right? In this case, you can also be equal to this. When you want to represent it by this, you just take the function itself and add I, j, k. So in this function, we can decide to take this function and remove this bracket and make it a closed bracket like this and just write 2x sine 5y, then I, then plus that, you see, and plus that g, as simple as that. So let's go to a concept which is called a conservative field. When you talk about conservative field, what does it mean? So a vector field in 2D, this is r exponent 2 is 2D, or in a 3D, which means that 2D means that it has two variables, and 3 r exponent 3 means that it has what? Three variables. It's called a conservative field or a conservative vector field if there exists a function such that the gradient vector field is equal to the what? The vector field, right? Yes. So that is, a vector field is conservative if it is also a gradient vector field for some functions. So when you have a function, right, and that function, we can find the vector is equal to the vector field, that means that that function is what? A conservative vector field. Let me explain this using this example that they give here. So for instance, the vector field of f, this one is equal to, so they've done the vector field for us, which is yi plus xg, is what? A conservative vector field with a potential function xy, because when you find the gradient vector field, you get this. So the difference between the vector field and the gradient vector field, with the gradient vector field, it's represented by this, and the vector field is this. Let's note that. So with the gradient vector field is a delta f, capital F, but with a vector field, you are finding the gradient vector field. In this case, you are adding I plus and the j. So the reason why they are saying that this function, this they said what? It's a potential function because f of y is equal to xy, because the gradient vector field is xy. Because when you partially differentiate this in terms of what? X, you're going to get y. And when you partially differentiate this in terms of y, you're going to get x. So in this case, this, because the gradient vector field is equal to the vector field here, the function is what? Conservative. But on the other hand, the reason why this is not a conservative vector field is because when you, because of this negative, because when you are taking this function, when you partially differentiate, when you're finding the gradient vector field of this function, you're not going to get negative y comma x. So since you're not going to get that, it's not a what? A conservative vector field. I hope you understand this concept. It's very simple, that when the function given to you and you find the gradient vector field, it should be equal to the what? The vector field, which means that it's what? Conservative vector field. Let's move on. So this, in this case, you are moving on to the curl and the dive. So we call it curl and dive. This also is very easy for you to understand. It's very simple for you to understand, the curl and the dive, right? So let's look at something. With the final one, we gave both the vector form in an equation as well as the parametric form. If we need the two-dimensional version, then we just drop one component. Yes, if you need one two-dimensional component, just drop the z, right? So in this case, the del operator has this. So the partial derivative of the function with respect to x, the partial derivative with the function with respect to y, the partial derivative of the function with respect to z, and you know it's ijk because it's a vector field, right? Whatever function that is listed after the what? The del is substituted into the partial derivative. So there's it. So this is it. So with this one, you're just partially differentiating this in terms of what? X, y, and z. And in this case, you're just going to add ijk, right? To know the vector field, right? Yes. So there's we have a way of finding the curl, right? So the curl. How do you find the curl? When it asks you to find the dive is just taking the function, partially differentiating with respect to the x plus partially differentiating with respect to y, partially differentiating the function with respect to z. In this case, when the variables are 2, then you are going to do it up to the y. When it is 3, you do that. So it depends on the function they'll give you. So we have the curl, right? And using the del operator, we define the curl over the vector field, which is equal to pi plus qj plus rk as the following. So with this is a product rule. this case is a product rule. So for you to find the curl of a function, right, you're going to use the product rule. I hope you understand. So in the product rule, we have the del operator multiplying the vector field, right? So the del operator multiplying the vector field. How do you do it? So now I'm going to explain this. So this is the way of finding the curl. So we'll do one example, but in this case I want to explain because this is just cross product and you know how to do it. So for the first one, you're going to cross here. You cross this and you cross this side. And you know that this side is going to multiply this minus this side is going to multiply this. That is why they had ry minus what? qzi. So you are going to partially differentiate the function of r with respect to y, partially differentiate the function of q with respect to z. Okay, sure. Then we move on to the second one. With the second one, what they did was let me clean this one. Let me take a different ink. Okay, blue. So for the second one, what they did was you cross this one like this. You're going to cross this in the middle. So then minus this will go here. So you're going to take r, partially differentiate with respect to x, and you take p, partially differentiate with respect to what? Z. Then plus, because this is minus plus. I get it. So let's know that it's minus and plus here. So then very simple as that. So you are going to you cross it like this. You take the function here, partially differentiate with respect to x, and take the function here, partially differentiate with respect to what? Z. In the other way around, let's do the last one. The last one, to what they did was you are going to cross it like this. Let's cross it like this. So in this case we have here. So you are going to take q will go here, and p will go here. So then we are going to take the function of what? Q, partially differentiate with respect to what? X. Then minus p, partially differentiate with respect to y, and then k. It's very simple. So at the end, finding the curl is very simple. It's like the normal way of finding the cross product of a vector. That is it. So very simple as that. So this is it. You don't need to memorize this formula in your head. Just understand how it goes, right? And let's see something, right? Let's move on. So one thing you must know is that for when you have the dive, right, and the dive multiplying the curl of a function, you're going to get 0. So then you have a function, in everything you have bracket first. So when they give the function and you find the curl of that function using the cross product, then you find the dive of that function, you are going to get 0. And if you get 0, that's the relationship between the curl and the divergence of the vector field, right? So let's take one example and let me explain that. So in this case, let's take how do you find the dive. For us to find the divergence of a function, right, they've given us x squared yi plus xyzj plus x squared y squared k. So in this case, they ask us to find the dive. What do you understand by the dive? You're going to take this, partially differentiate with respect to x, take this, partially differentiate with respect to y, take this, partially differentiate with respect to what? Z. So the I is for x, j is for y, and k is for z. Not the variable you are considering. You are considering the function, the vector I, j, k. So here, the dive of it, you are going to take what? When you do it, you are going to get 2xy. That's why they had 2xy. Are you getting it? And here, when you partially differentiate with respect to y, you're going to get what? Xz. That's what you had here. And when you partially differentiate with respect to k, with the k, we are going to do it with respect to z, right? And in this case, we don't have z here, so it becomes 0. That's why they had this. So you're going to get 2xy plus xz. Very simple as that. So the dive, finding the dive is very simple. Taking I, partially differentiating with respect to x, j, partially differentiating with respect to y, and k, partially differentiating with respect to what? Z. Let's prove it. They said something that when you find the curl of a function of a vector, the vector field, when you find the curl, and then you find the dive, you should get 0. That is the relationship between the divergence and the curl, right? So let's do that. So we have a vector field here, which is what? Yz squared I plus xyj plus yzk, that one. So please in the comment section below, I want you to find the dive of this function for me. This vector field, find the dive for me so that I just want to see the dive. So I know you've done it, and for the dive, even though it's not part of the question, I want us to do it. We're going to get what? Here will be what? 0, because there's no x here. and here will be what? Plus what? X, right? And this is what? Plus what? Y. So you're going to get X plus Y. So in this case, you're going to find the curl, right? Let's find the curl. The curl, I told you that first you're going to cross this product, because first you need to write ijk, then here is partial derivative with respect to s, partial derivative with respect to y, and partial derivative with respect to z. Then first one, you cross this one like this. Let's cross it. Then you're going to take this one, partially differentiate with respect to y. That's what they did here. Then you're going to take this one, partially differentiate with respect to z. So when you take this partial differentiate with respect to y, what are you going to get? You're going to get z, which is z, minus, when we take this one, partial differentiate with respect to z, you're going to get 0. Then you're going to get zi. That's what they had, the zi. Let's take the second one. Let me change the color. With the second one, we are going to cross this side, the middle side, right? So we are going to cross the middle side like this. So when you cross the middle side, right, you're going to get this mapping to this, right? So then you're going to differentiate, partial differentiate it with respect to what? X. So when you do that with respect to x, what are you going to get? You're going to get 0, because there's no x here. Then minus, please don't forget that you have a minus sign here. So minus bracket open, you're going to get, when you partially differentiate it with respect to x, you're going to get what? 0. Then you're going to take this, partially differentiate it with respect to what? Z. And that will give you 2yz. 2yz. I get in this. So at the end, you're going to get 0 minus 2yz. And there's a negative sign here because it is minus plus. So negative sign here, which will give. Then let's go to the next one, plus. So the next one too, we are going to use the same principle. Let me clean this one. We're going to cross the last one, which is, when you cross this side, let's cross it like this. And you're going to take xy. So when you take xy and partially differentiate it with respect to x, what are you going to get? You're going to get what? Y, right? Minus, we will take this one, partially differentiate with respect to z. So guys, let's do some correction here, right? After getting it, this is gonna give you what? Plus 2yz. So it's yz, not xy. So this is z. This is z, right? So then let's try and prove that whether when you find the after finding the curl and you find a dive, will you get 0? So you're going to do this partial differentiate in terms of what? With respect to x, you're going to get 0. Then partial differentiate this in terms of y, you're going to get what? 2z. Then partial differentiate in terms of z, you're going to get what? 2z. So at the end, you're going to get 0, which simplifies that when you find a curl of a vector field, then you find, after finding the curl of that function and you find the dive of the curl, you're going to get 0. That is very simple. So this is how you find the curl and the dive. As very simple as that. Thank you very much for watching this video, and I hope you like the video.